Okay, sample problem 19.6. Predict whether the following reaction will occur spontaneously as written at 298 Kelvin. Cobalt solid plus iron 2 aqueous goes to cobalt 2 aqueous plus iron solid, assuming that the concentration of cobalt 2 is 0.15 molar and the concentration of Fe plus 2, or 2 plus, is 0.68 molar. So spontaneous means the cell potential. If the cell potential is positive, then it's a spontaneous reaction. If it's negative, then it's non-spontaneous. Okay? So here's what we'll do. We'll just calculate. Let's just go ahead and figure out. It doesn't actually ask us for the value, but if we calculate the value of the cell potential, then we'll find out whether it's spontaneous or not. Okay? So you have your choice how to go about this. I wrote the standard reduction potentials and the equations associated with the half reactions for the two relevant reactions. Okay? So if we take a look, it looks like what's happening in the reaction is cobalt is going to cobalt plus 2. Cobalt going to cobalt plus 2 is oxidation, so that means the cobalt is the anode. Iron 2 is going to iron. That means it's getting reduced, so that must be the cathode. So now the standard cell potential for this reaction would be the cathode potential, which is minus 0.44 volts, minus the anode potential, which is minus a negative 0.28 volts. Sorry. So that's what? Negative 0.16 volts. So if everything were 1 molar, meaning the iron 2 was 1 molar and the cobalt 2 were 1 molar, standard conditions, this reaction would be non-spontaneous because you have a negative potential. But they varied the concentrations. The concentrations are not 1 molar. So what we really got to do is we got to calculate this. This gives us a part of a clue, but we need to know the second part here. So let's figure out what Q is. Q is the concentration of cobalt 2 over the concentration of iron 2. Remember how we did that back in chapter 15, way back at the beginning of this course? How do you write the expression for Q? Cobalt 2 is 0.15, and iron 2 is 0.68. Okay, so 0.15 divided by 0.68, that's going to give you Q. 0.221. And then in the equation, we need to know log Q, so I'm going to calculate that next. Okay, so we'll come back to our calculator here. There's our 0.221. Take the log of that. Negative 0.656. Okay, so now we've already figured out that the standard cell potential, the cell potential is what we're trying to calculate, is the standard cell potential, so minus 0.16 volts, minus a minus, right? This is minus here. The log of Q is minus, but we got a minus there, so it's just plus. 0.0592 over n. Now let's figure out what n is. That's easy. Both of these have the same number of electrons, 2, so n is 2. Okay? And then log of Q we said was what? Negative 0.656, right? See why I'm putting 0.656? It was minus, the equation is minus. But this term here was minus, so minus a minus is plus. So now we've got it. So let's do 0.0592 over 2 times 0.656. So I guess we could just add it to our negative. Do we have the negative 0.16? Oh, we don't. Okay. So let's come over here. So 0.0, let's write it out. Plus, I know that'll be positive. 0.0592 over 2 times 0.656. Oops, sorry. 0.0592 over 2 times 0.656. 0.0194. Okay, it doesn't look like it's going to work, right? It doesn't look like that's a big enough positive value to overcome the negative 0.16. So if I subtract from that 0.16, you still get a negative 0.14. Non-spontaneous, right? This reaction as written with these concentrations is non-spontaneous. In order for it to be spontaneous, that reaction would have to be positive, right? E cell would have to be positive. So this second term here would have to be more positive than the first term is. For that to happen, this would have to be a bigger number. But if it was 2, then it might work, right? Or if it was 3 or something like that. If it was a large enough value, then it would work there. But 0.656 is just not big enough. You still have a negative potential, so this is a non-spontaneous reaction.